All right. So most people got that part. Let me see what the next part is. Okay, so ask you to state your null hypothesis, your research hypothesis, and then to get your mean for each group, right? So all of that is very similar to what we've done before. Any questions so far with just getting the means and the group means or the null or research hypothesis? No? Okay. Okay, cool. All right. So, oops, I have, hold up. Okay. So we have now, we have to calculate the within group sum of squares and the between group sum of squares, right? So that's sort of our first step with calculations. So can everyone see this table here with my variables of x, y, and z? Chat?
Yes.
Yes, okay. Yeah, chat, maybe. Sorry, I can't see my chat. Yes, okay. Cool, okay. So let's see if we had our problem like we did here. So we had 2, 2, and 3. And then our next variable was 4, 4, and 3. And then our last variable was 5, 6, and 4. So these are values of x. And so most people got the next step, which was to calculate the mean for each group. So I want to calculate my mean for x. I got 2.33. I think some people rounded a little bit differently, but that's okay. For this mean, I got 3.67. And for this one, I got a mean of 5. And so we have each of our group means. To get my within group sum of squares, what you're looking for is the variability, or here kind of essentially the variance within each group. So this calculation should look pretty familiar because it's just like we did to calculate variance. We took each value of x and we subtracted the mean. And then once we did that, we then squared that value. Right, so here it would be basically 2 minus 2.33, 2 minus 2.33, 3 minus 2.33, right? And so I would calculate each of those out and then square them. And so let's see, once I did that, so 2 minus 2.33, and then take that and square it, I get 0.11 for each of these and 0.45 here. And then I simply add these together, right? So let's see, 0.11 plus 0.11 plus 0.45 is 0.67. So that's my sum of squares for x, but I need to do this for each variable. So this one would be 4 minus 3.67, 4 minus 3.67, 3 minus 3.67. And then I would, so that's my y minus m. And then I need to square that. And so here, I got also 0.11, 0.11, and 0.45. So this should be, if I sum all of these together, again, 0.67, because it's the same numbers. And then, of course, we got to do it for the very last group. So 5 minus 5, 6 minus 5, and 4 minus 5. And so if we take those and square them, this should be 0, right? This would be 1 squared, which would be 1. 1 squared, which would be 1 again. So this sum is 2. Okay, so if you remember with this here, let's see. So we've got each of these. Let's go back to our overall formula, right? So it says compute the sum of squares for each group, called the sum of squares within. So that is the sum of x minus m squared. Okay, so we just need to add all of these together. So let me double check, and we should get plus, what was it, 2? Yep. So if we add these together, so 0.67 plus 0.67 plus 2 gives us 3.34. And so that is our sum of squares within, or sum of squares within groups. Does that make sense so far? Maybe.
Yes, it is.
Okay, good. So we're about halfway, right? So that's our first step. So that's number 10. And then I think Cami said she got that one, but then it started with number 12. All right, so, oh, and so you also got the between group sum of squares as well. So our between group sum of squares, to calculate this, what we need to do, we've got each of our group means, right? So that's our 2.33, our 3.67, and our 5. So we have each of our group means that we need. What we need to do is calculate this total mean or this grand mean. And so what that is basically if you took all of these groups and put them all in one pot and added them together and divided by the total n, what would the mean be? So I would take all of this, right? I would want to add my 2, 2, 3, my 4, 4, 3, and my 5, 6, 4 all together and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that should be, anyone has it? 3, 4, 4, 3, 5, 6. Oh, 5, 6, 4. I'm double checking myself. 33 divided by 9. So if I add all of those up, I get a total of 33, and then I divide by my total sample size of 9, which will give me a grand mean of 3.67. Grand, or a total mean of 3.67. And now what I want to do is I want to take each of my group means and subtract this 3.67 and square it. So I would take my 2.33 minus 3.67, and I would square that. And so that should give me 1.80, right? Hopefully. I'm gonna give me one more column below here. Okay, and then I want to take my 3.67 minus my 3.67. So that will be 0, and 0 squared is 0. And then I want to finally take my last group mean of 5 minus my 3.67 and square that. And that should give me 1.77. Now, if you look back at this formula, so it says take each group mean minus that total or grand mean, square it, and then multiply it by the group size. Right? So that's essentially weighting each of these values by the size of the group. So here, every group has the same amount of people, right? So all we need to do is multiply this 180 by 3, 0 by 3, which will just be 0, and 1.77 by 3. And so that should give me 5.4 for that one, 0, and 5.31. Now, finally, it says sum all of these together. So I'm going to add 5.4 plus 0 plus 5.31 to get my sum of squares between groups. So when I do that, and I add 5.4 plus 0 plus 5.31, I get 10.7. All right, so I have stated my null hypothesis, my research hypothesis. I've gotten each of my group means, and I've used those group means to get my sum of squares within. And I've used them and the grand mean or the total mean to get my sum of squares between. And if you look, like we talked about before, we have a ratio of the variability between groups over the variability within groups. But how the formula is actually stated is looking at mean squares. So here, F, how it's calculated, so it's the variance between groups over the variance within groups. But really what we're looking at is mean square between groups and mean squares within groups, or mean squares error. So all that is saying is that we have to take these sum of squares and compute mean squares by using our degrees of freedom. And let me see, where do I have my formulas for degrees of freedom to walk you through this? Okay, measures of in or so here's my degrees of freedom. So my degrees of freedom between groups is k minus 1. My degrees of freedom within groups is n minus k. So this would be the total sample size minus the number of groups. This one is the number of groups minus 1. So if we wanted to, I'm running out of room on my table. If I wanted to get my mean squares, let's see, number 12 asks for mean squares between groups. So that is my sum of squares divided by basically my degrees of freedom. So I've got my 10.7 divided by k, so my number of groups, 1, 2, 3, minus 1, which would be 2. So 10.7 divided by 2 is going to equal 5.35. Okay. And then my mean squares within is my sum of squares within groups divided by my degrees of freedom. And so we had 3.34 divided by our total n, which is 9, 3, 6, 9 people overall, and subtract my number of groups, which is 3, 1, 2, 3. And so it's 3.34 divided by 6. 0.56. Does that make sense? Everyone with me?
Yes. I have a question.
Mm-hmm.
Or whenever you said the sum of squares divided by degrees of freedom.
Mhm.
3.34 divided by 6. 6 is the degrees of freedom as well.
Yeah, so the 6 is the degrees of freedom error, or the degrees of freedom within groups.
Okay.
And then this one is the degrees of freedom between.
Got
And
it.
so those formulas, degrees of freedom between equals our k minus 1, or our number of groups minus 1. So we had 3 groups, minus 1 is 2. So that's where we got that 2 from. And then my degrees of freedom within, or degrees of freedom error, it kind of depends on which book you're using, how they label it. Oh no. So that's why I try to put both, just in case, you know, you're looking on different sources. Okay, so that is your total sample size minus your number of groups. So we had in total across all the groups 9 people, or 9 data points, right? And then minus my number of groups, which is 3. So it'd be 9 minus 3, and so we got the 6.
Okay, got it. I think my problem was whenever I was doing or trying to do the homework was that at the beginning, whenever I started adding the hot day, warm day, and cold day, it gave me the total of 33, and then that divided by 9.
Yes.
First of all, I didn't round it. I didn't round my answer, and that made me messed up on everything. And then also, whenever I was adding the sum of squares for hot day, for example, I was subtracting 2 minus 3.60, which was my initial answer that I didn't round.
Oh, so that's what I was saying in the email. So what you need to do here, so this 3.67, that's your overall total mean, right? But before you do that, if you're taking each value of X, or each value of hot day, right? So hot day, warm day, cold day. So if you're taking each of these values, what you need to subtract from it is not this overall total mean, but instead the mean for just this group.
Okay.
Right? So you would add each of these up and then divide by 3 to get this mean of 2.33. And then I'm taking 2 minus 2.33, 3 minus 2.33. Right? And then the same thing for warm day. You would take 4 plus 4 plus 3 divided by 3 to get a mean of 3.67, which is the same, right?
Yeah.
So for that one, you don't need to change anything. But here you would need to, because if you do 5, 6, and 4 divided by 3, you get 5. And so I took each value for cold day and subtracted 5 and then squared it.
Correct. Okay. Yes, that was I guess that's one of the reasons why I probably couldn't move on forward, because I didn't get that right at the beginning.
Yes, yeah.
But thank you for clearing it out.
Yes. So, and it's not, you know, here with the formulas, it's not really clear, because if you look, it says to compute sum of squares, do X minus the mean, right? It should, I guess I should say like mean sample, right? And then where you use that overall total mean is here in the calculations of the between group sum of squares. That's where you would use that.
Okay.
Okay, so we had, let's see, any other questions about getting mean square between, within, sum of squares?
No, not for me. Not right now.
All right, so we've got our mean square between and our mean square within. If we want to get our F, if we look here, F is mean squares between divided by mean square error, or mean square within. right? And so all we need to do is to take this 5.35 divided by 0.56 to get our F. So our F would be our 5.35 divided by 0.56, which should be 9.55. So that's our F value. All right, and then just like we've done before, you just use this as your calculated test statistic or your calculated F, and you compare it to an F critical value that you get from the table. So let me pull up the table really quick. Critical tables. And so it is our F table that we're using. And then we already have our degrees of freedom, right, that we need to use. So we had our degrees of freedom of 2 and 6. So you just find where 2 and 6 meet at the 0.5 level. And so our critical value is 5.14. And so what you're looking to see is the value that you calculated for F of 9.55 greater than this critical value of 5.14? And it is. And so you say, yes, it's significant. And so since it's significant, you reject your null hypothesis. And so that part's kind of the same as what we've been doing. 10.71. Oh, hold on. I have something from Carrie. 10.71. Oh, versus 10. Yeah, 10.71 is fine. Yeah.
So when we round, like the, where is it? Like for, can you go back to the table? I'm trying to see it from like your screen. It was the 3.67 minus 3.67, and then you square that. And it gave me like a bunch of zeros and then a 7, or I'm sorry, it was 4 zeros and then a 3. So that would, you would just round that up to a 0 instead of like, oh, okay.
I usually round to 2 decimal places.
Oh, okay. Okay. Yeah, that was it. That was my question on that. Thank you. For the project, are we gonna do, I know it's like similar to this, we would just do our own calculations like that as well?
Yeah, so you can do your own calculations, or if you want, you can do this in Excel. So let me show you, and you can actually use Excel to check things. So I gave you, I've already posted the Excel files. If you want to do it by hand, wait a moment, because I will, I'll give you a shorter data set, because the data that I put, that would be way too much to try to do by hand. It's really quick in Excel. It doesn't really matter how much data you have in here, because it's calculating it for you. But if you wanted to do this in Excel, so I just put in our data for, actually, let me, well, come on. Okay, this was hot day, warm day, and cold. And then this is the same data that we were working with, 223, 443, and 564. So what you can do is go up to data and data analysis. And if you don't have data analysis, if you go to file and options, it's an add-in for Excel, but it should already be there. All you have to do is click on it and say, yes, I want you to add it in. So I've already added it in and click cancel. And so if you go to data, if you've added it in, you should see data analysis. And what you can do is say, all right, I have these 3 groups I want to do an ANOVA. What we're doing is single factor, or as your book says, one-way ANOVA, but it's basically saying that there is one variable of type of day or weather or temperature, I guess, right? And then we have 3 groups based on the temperature. So I'm going to say ANOVA single factor and say okay. Input range is just asking you to select your data. So I'm going to do that. It's going to select it. It's grouped by column, so I have each of my hot, warm, and cold in different columns. The labels are in the first row, where it's labeling what the group is. And then I click OK. And then it does it for me, right? So if you see, it calculates everything that we've been doing. So you have each of your group means or averages. Then you have your sum of squares between groups, your sum of squares within groups. You have your degrees of freedom of 2 and 6. You have your mean square of 5.33 and 0.56. You have your F of 9.6, and then they have your F critical here, and they're actually calculating your p-value. But remember that if this is larger than this, then it's significant.
So the p-value is just something extra that they add, or we don't have to worry about that, right?
So your p-value for your project, this is what you'll report. Right? You'll report several things, and we'll kind of walk through that. And I'll give you guys some resources and some tutorials about what to pick out and report. But you'll report your p-value. And what you're looking for is for this p-value to be 0.05 or smaller. And if it is, that means it's significant. So, essentially, this is telling you redundant information, right? So your F is larger than your critical, and so it's significant, and that's what your p-value is telling you, that yes, it's significant. But if you'll notice, if you read like research articles, they usually don't tell you like F critical values. Instead, they tell you the p-value.
Oh, okay, thank you. Because I didn't see that on the homework, so I kind of realized that I don't know if it was relevant or not to this, but it will for the project, right?
Yes, yeah, it will for the project, unless you're doing it by hand. So the reason that we're not doing it in the homework is because we're doing it by hand, and we're not getting the p-value by hand. So if you pick that for your project, then you don't have, if you pick to do it by hand, then you don't have to report your p-value. Instead, you would report your F critical.
Oh, okay. All right, thank you.
Yeah.
You also, sorry for the interruption. Can you just briefly tell us a little bit about the project now that we're going to be doing it individually?
Yes. So let me see if I can. Okay. So in your Canvas under modules, I changed things up just a little bit. It won't change a lot, but if you'll notice, you have a new outline and a new submission theme that's individually. But you'll see here you have 2 data sets. So this is if you're doing it in Excel. So you notice that each of these are Excel files. And like I said, if you choose to do it by hand, I will post a modified data set that'll be easier to do by hand. But let's say that you say, okay, I want to do it in Excel. And you can pick either one of those data sets. They're just different things, just different sets of data. And neither one is going to be more difficult than the other. But this is our NFL data set. And so you have a kind of brief description. And so it's telling you each of these variables are the weights of players from different NFL teams. So like X1 is the weight of players from the Dallas Cowboys, so on and so forth for these 5 different teams. And so these instructions just say, pick any 3 teams that you want and conduct your descriptive statistics and then conduct an ANOVA. And so it'd be doing the same thing that we did before. You would pick whichever 3 teams you want. Maybe you don't like, who is it? The Denver Broncos. You're like, I want to get rid of them. Okay. And you're like, no, I don't want the San Francisco. And so you're saying, okay, I want Dallas Cowboys, Green Bay Packers, and Miami Dolphins. And so you select your data and you go and you do your data analysis and you click your ANOVA and run your ANOVA. You can also, if you want to do descriptives through like formulas, like this way equals average and get your averages and so on and so forth, you can. You can do it that way, or with this data analysis tool pack, you also have a shortcut for that as well. Because if you look, data analysis, descriptive statistics. So these instructions say, run an ANOVA and also get your descriptive statistics to report. And so all you have to do there is say, okay, I want that. Let me select my data. I'm gonna say summary statistics, labels are in the first row. Oh, see, and it gives me my mean for each group. It gives me the median for each group, the standard deviation for each group, the range if you wanted that, and this count is a sample size, the total number of players, and that should correspond, if you add all of these up, there's 17 players that you have data for each team.
For
Okay.
Excel, does it automatically do a second sheet for like if you do descriptive? Oh, okay.
Yeah. So if you notice, if you toggle back and forth here, what it's doing, yes, it's creating a second sheet. And if you look, you can change that if you wanted to. So you could have it put it in a whole new Excel file. I have it where it's putting it in a new sheet. You could even have it put it in the same one, and you just have to tell it where to put it, right? In that case. But yeah, so this is saying in a new worksheet. And so it creates that as soon as you click OK to run it. And so the sheet 1 was where all your data was. It created a new sheet that has all of your output, where your results. But like I said, I'll post some tutorial documents and a video to kind of help walk you guys through that.
Okay. Thank you very much for clearing it out for us.
Yeah.
Thank you. And I had one last question. At the bottom of the instructions, it says be sure to state your null and research hypothesis. Would we do that within the Excel sheet or in the paper?
In the paper, in the APA.
Okay.
Right up, yeah.
Thank you.
I had a question regarding our homework for this week.
Mhm.
So I know we're talking about chi-squares 1 and 2. For the homework, is it only focusing on one, or is it focusing on both?
On both. Hold on, let me pull that up really quick. Okay, that is homework 7, right?
Yes.
Okay.
Because your ANOVA tutorial helped me a lot. So I was actually able to just follow along and complete my homework for last weekend. So for this weekend, I noticed when I try to go on the tutorial for it, for the chi-square 1, it wasn't working. So the video was unavailable.
Yeah, that one's messed up. I'm gonna fix that and repost it.
Okay, I just didn't know if we needed to I need to go through both of them.
Yeah, so I will post that later today.
Okay,
because you will need both. So if you look here, this 6 through 10, this is the one-way chi-square. Because you have just one variable. You have flavored drinks. And then this is the number of people who liked the swizzleberry, and this is the number of people who liked the creamsicle.
Okay.
Right? And so that's your one way. And then the two way is this 11 through 15, where here you've got two variables, life satisfaction and job security.
Okay, perfect.
Yeah. And then the same way for this one is the two-way, education and then income.
Okay, thank you. I just wanted to make sure because those tutorials really do help a lot.
Oh, good. Yes, yeah, so I'll fix that one and get it posted.
Okay, thank you.
Any other thoughts?
I had one